What's going on, everybody? It's Kistner again, and welcome to lesson 2-2. This one's called Standard Form of a Quadratic Function. Let me fix that. Now, in your workbooks, turn to page 36. Go ahead and turn to page 36. We're going to skip the critique and explain on page 35, but it's lesson 2-2 on page 36 in your student companion, or you can take these by hand. They're not too painful to take by hand on your own paper. But let's get right into the first example. It's pretty straightforward. It says, what is the x-coordinate of f of x if ax squared plus bx, if f of x equals ax squared plus bx plus c? Now, this is going to be kind of a watch page. You don't have this in your notebook. But this function right here, f of x equals ax squared plus bx plus c, is something we call the standard form of a quadratic function. Think of this as more of the y equals mx plus b version of it. Y equals ax squared plus bx plus c, where a, b, and c are real numbers and a cannot be 0. So we're going to use the vertex form to derive standard form. We'll do that in class at some point. It's kind of messy, and it's not really that necessary. But you can use the vertex form. If you remember, vertex form from last class was y minus k equals a times x minus h squared, or y equals a x minus h squared plus k. The same thing, okay? Same thing. These two are the same. I just bring the k over. This is vertex form. And it's really easy to tell where your vertex is from vertex form because h and k are listed explicitly. They're not so much listed explicitly in ax squared plus bx plus c. There's no h and k. Remember, your vertex will always be h comma k. Always. So how do we do this? Well, we solve this nice thing using our vertex form, and you'll see some things start to happen. But what's nice is the vertex of the quadratic function is hk. So to determine this, there's a nice little shortcut. And this sorry about that abrupt stop. I got interrupted here in my room, but let's finish this. So the vertex of a quadratic function is h comma k. So to determine the x-coordinate, like I said, there's a nice little shortcut. The x-coordinate of the vertex, or h, will equal negative b over 2a. Now, where do b and a come from? That's the b and the a up here, out of y equals ax squared plus bx plus c. So it's really simple to do. If you can look at what b is, the coefficient in front of just the middle term, the x term, and you look at a, you can plug it into negative b over 2a. K will be f of negative b over 2a. Now, what does that mean? That means once you know what h is, you just plug it in. This will be an x-coordinate, remember. This is the x-coordinate of the vertex. You just plug it in for x, and you'll get a y. You can use a calculator to do that. It's really nice and simple. Let's practice that. What is the vertex of the graph of the function f of x equals x squared minus 8x plus 5? Well, let's first write down what a, b, and c are. A is the coefficient right here, so it's 1. B is the coefficient on the x term, so it's negative 8. And c is 5. By the way, it's really nice to know that c is going to be your y-intercept too. This is a nice little piece of information. So I want to know h comma k. H is negative b over 2a, and k is going to be f of negative b over 2a. So in order to do that, I say, okay, it's going to be negative of negative 8. Now I'm writing this out in a lot of detail right now, just so we can see it for the first time. And it's 2 times a. So that is 8 over 2, or 4. Okay, 4. And now if we plug 4 in here, we can almost do that in our heads. That's going to be 16 minus 32 plus 5. Just plug in 4. X squared minus 8 times 4 plus 5. So that's going to be negative 16 plus 5 is negative 11. So my vertex here is negative 11. Or sorry, is 4 negative 11. And of course, you can always check that by using your calculator and coming up here and typing it in. We said it would be 4 squared minus 8 times 4 plus 5, and you get negative 11. There it is, 4, negative 11. Plug in a 4, you get a negative 11. That's your vertex. That's how you find the x and y coordinate of your vertex. Negative b over 2a, then plug that number in. It's that simple. All right. Use the key features up to graph the function. Now, the key features here is we definitely need our vertex. So let's find our vertex. Okay. That's one that we have to find. We need our y-intercept and our axis of symmetry. If we can find these three things, we can graph any parabola. All right, any parabola. Really, all you need to graph a parabola is three points. Like a line, you need 2. A parabola, you need 3. But we're going to use 4 to make it extra accurate. So let's fill this stuff in first. The vertex here is going to be negative b over 2a, which is going to be negative of a negative 6. Let's keep this going. Let's actually write down what a, b, and c are again. A is 1, b is negative 6, and c is negative 1. So, negative b over 2a would be negative of a negative 6 over 2 times 1, which is 6 over 2. So it's 3, comma, and I'm going to use my calculator just to plug it in and say it's going to be 3 squared minus 6 times 3, and then minus, not negative, minus 1. I believe that was the right order. 3 squared minus 6 times 3 minus 1. And I'm going to hit enter, and my vertex is negative 3, negative 10. Okay, so let's start graphing this thing. And I'm going to make sure I have 10 here. So I'm going to make this a little bit higher. Let's see if I get it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, here's 10. So my vertex is at 3, 1, 2, 3, negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll put a point right here. That is 3, negative 10. Okay, now what's really nice is we should already know the axis of symmetry. The axis of symmetry, remember, runs right through your vertex. It splits your parabola in half. So if I'm going to do that, I know it's going to be an x equals line, and it's going to be x equals h, which is 3. So x equals 3. So if I make a dotted line, because it's not really on our graph, I'm going to make a dotted line out of it. Oh, I'll do it different. I'll make it blue. It comes through, right through this point. Okay? It comes right through there. Like that. There's my axis of symmetry. Now what that's going to do for us is once I figure out the y-intercept, and I told you the y-intercept is c. Y-intercept is c because we let x become 0, and that's 0 squared minus 0 minus 1. So c is the only thing that's left. That becomes negative 1. Becomes negative 1, and I'll plot that. So the y-intercept is at 0, negative 1. So it's all the way up here. Now parabolas, I said I was going to use 4. I'm actually just going to use 3 points. Parabolas are symmetric. So if it's 3 away from the axis of symmetry, the point that it's in the middle, I can count 3 to the right and put another point, and I now have enough points to draw in my parabola. Now notice I'm not using x-intercepts here. We're going to get into how to do that. But my parabola runs right through these 3 points. Your y-intercept, your vertex, and then what we call a symmetric point. because it's just flipped over. So those are the only 3 points you need to graph a parabola. Let's look at example 3. A water balloon was thrown. This is going to be talking about interpreting, by the way. A water balloon was thrown from a window with the height of the water balloon over time is modeled by this function, negative 16x squared plus 160x plus 50. What is the maximum height of the water balloon that was thrown? That's asking for this point, way up here. We know that as the vertex. So this is really asking, what is the vertex? That's what this is asking for us. So all these with this nice big word problem is just basically saying, what's the vertex? What is the maximum height? Means, what is the vertex? So we know how to find the vertex. Remember, h comma k is equal to negative b over 2a, comma f of negative b over 2a. So we just plug that in. Here's our equation. Let's write down what a, b, and c are. A is negative 16. B is 160. And k is 50. Sorry, I don't know why I just put k. Sorry. C is 50. We don't really need that today for this one, but we're going to write it down anyways. So plug it in up here. H comma k is equal to negative b over 2a. So it's negative 160 over 2 times negative 16. And if you're not too confident about that, that's going to be negative 160 over, sorry, it's, yeah, negative 32. So in your calculator, you can do that. Negative 160 divided by negative 32. Get 5. Then you plug that in. F of 5 is going to be negative 16 times 5 squared, ax squared, plus 160 times 5 plus 50. Notice how I'm using my parentheses. It's very important. You get 450. So this is your vertex. I want to know the maximum height. And notice that the height is on the y-coordinate axis, the y-axis here. So really the only point that I'm concerned about is the 450. The maximum height is 450, and it's in feet. So feet. This is the final answer. So that's how you interpret something. If you can just determine, like, it's asking for the maximum height. If it had asked for how tall it was thrown, we'd have said, well, it's going to be C, 50 feet, because that's the y-intercept here. Okay? So there's a lot of different questions they could ask. All right. So I'm going to stop the video here. Nice little 13, 14-minute video. Make sure you understand these notes. You've written down all the examples. We will talk more and take questions on it. Make sure you've done your last assignment. And I will see you guys next time. This is Kistner out.